Is it visible now?
Yes, sir.
Okay. So we will start. So last time we started analysis and design of the rectangular tank by using StatPro. So I will open that PPT also. Okay. So with reference to these steps, so we have completed last time the modeling of the basic tank. After that, we have applied the different element properties to our wall, base slab, top slab. We also applied the supports. So we came to know that how to calculate the subgrade modulus of reaction for the base slab since it is resting on the ground. So how to assign those if we don't have any information from the geotech report. Okay, so once everything is done, we have conducted some different checks. So we are making sure that our model is correct. There is a no error. Okay, after that, we have applied different loads in terms of hydrostatic and soil static from outside. We also applied soil surcharge from the outside. Okay, so after that, we added some load combinations. So till 1 to 6, these steps are we have done last in last session. So now today we will complete the remaining things. Okay, so analysis, check for the deflection, and we will start to extracting the results. Okay, so if we go to this loads, we have completed all the loadings. We have added different types of load combinations. I think yes. So uplift pressure also we have last time calculated, applied. Okay, so now next will be the analysis. So for that we have to go to this command, then go to the uh, diff analysis. Just add, click to the perform analysis. You will get some these options. So maybe we can just select anyone, but preferably I can just check the static checks. Okay. Now go to the analysis tab, run analysis. It will take few seconds or couple of minutes to complete. Yes, so done. So here we can get few options: view output file, go to the process post processing mode, or stay in the modeling mode. So generally I just choose this one. Done. So after that we can go to the post processing mode. So this tab is here. So while this, what I will choose, because first I want to check deflection whether it is safe or not, and deflection is always we consider for the only service level combination. So that's why I've selected only 100 series load combinations like 100 to 103. So I selected only these service level load combinations. Click on OK. So there are we are getting deflection. So I just more interested in summary. Okay. So now you can see the maximum deflection of entire tank that we are getting here. So right now we don't know whether it is for the base slab, whether it is for the top slab, or whether it is for the wall. So this is entire package for all of this. For all tank we are getting this summary. So just see what is we are getting. The maximum deflection is 8.116, and if you select this you can see this point. Okay, so so based on this we can know that this maximum deflection occurs to the top slab. Okay, so what is the allowable deflection for the top slab? So our, I think the internal width is 8 meter. So 22 deflection is allowable, so we are getting less than that vertical deflection. Okay, so we are safe. Understand what I want to say?
Yes,
Yes.
sir.
Okay, because span of the width of the shorter span of the tank or shorter span of the top slab is 8 meter. So for that 8 meter, maximum allowable deflection is 22 mm, which is way more than 8 mm. So yes, so in terms of deflection, my entire slab is safe for the vertical deflection I am talking. So because of the lateral load, like for the wall and those things, so there are lateral deflection also, like wall will try to deflect, correct? So that's why we are getting some values for X and Z also. Okay, so for X dimension, you can see this wall panel is getting deflected by 1 mm. Okay, and I think we have maximum height of the wall is 5 meters. So 5 point divided by 0.360. 5 divided by 360. So 13 mm deflection is allowable for wall. Even though based on these values, I can say by observation deflections are okay. So all good. So same thing with the Z axis also. Maximum deflection is a 1.2 mm for this wall panel, which is deflect into along the Z axis. Okay, so for all walls, we can get maximum allowable deflection is 30 mm, so which is way less than that. So okay, and if you want to see the deflection for particular element, so that can be also possible. Suppose I want to see the deflection for only for the top slab. So how I can see this? So just right click it, go to the result setup. You already created some different groups. So go to that result view options, range, go to the range. You already created groups. 1 second. I got one. मी तुला करू कॉल 8 नंतर. अच्छा ठीक आहे. माझा एक क्लास सुरू आहे. हो सर. ठीक. ओके. Hello. So we already created different groups. So just go to that group. So yes, now you can see if you want to see the deflection for only base slab, just click OK. Now all the values are get changed. So now you can see the all the corresponding values. Those are just for the base slab. If you want to see those for the only top slab, yes, you can do that. Go to the groups, group slab. So now all the values now will be corresponding to this top slab. Similarly, if you want to go to that walls, maybe either a long wall or short wall. So now all these deflections are with respect to the long walls only. So if you want to some different things with for instead of you want see individually deflection for individual elements for wall slab, yes, so we already created groups, and that based on that, yes, you can do that. Okay, understand this point? Check for deflection. And analysis means yes, only it's a command, so we have to just apply that command, and after that we have completed this checks for the deflection. Okay, any questions till now? How to see the deflections? Okay, I am assuming all good. So now since deflections are okay, so maybe it's okay to go to the next stage, that is extracting the results. Okay, so how to extract that results? So basically first I will just select, or maybe since we are using the plate model, so how to see that results in terms of bending moment and that. So before that I want to go to the one basic things for the plate. Yes, so analysis. So these image is taken from the STAAD. STAAD help. If you go to the F1 or if you open the STAAD, you can get this image. So it is very very important understanding of this image or figure. I will try to. Yes, is it visible now?
Yes, son.
Okay. So now we are going to extract the results from the STAAD. But how to extract? So before that, we need to just know the understanding of that plate, how that plate, each plate will be behavior. Okay. So our ultimate is that we are going to find out mx my, correct? Moment in x direction, moment in y direction for every element. We need to find it for the base slab, we need to find it for the all four walls, and we need to find it for the roof slab. Okay. After that, we have to find out the shear force also. Okay, that is in terms of xqx and xqy, because we are getting the shear force in both direction. Okay, so how to find out that mx my? So if you see this figure, so this is one example plate, so I'm just taking only one plate. Hmm. At the same time, I will take this plate, any plate. I will go into the modeling. I have opened the its orientation. Okay, so this is one plate, and okay, so same thing, like you have seen this in my style, we have just kept only one plate. So for for each plate we have local axis. I'm talking about the local axis, not global axis. Okay, suppose as per this snap, this is one plate and its local axis like this, x, y, and vertical z axis is upward. So the moment which is parallel to the local axis, so that is called as a local x. Okay, can you see this arrows, different arrows, mx?
Yes, son.
Okay, so mx means which is parallel to the its local axis, that is a mx. And same way, the moment which is parallel to the local y, that is called as a my. Clear?
Yes, son.
Okay, and same thing, the xqs means the shear force which is parallel to the x-axis, that is a shear force. Same thing, the shear force which is parallel to the sqx, which is parallel to my. Okay, so now I am going back to my stat, or maybe I can print this. I will open the paint. I will draw this. This is the moment m. Okay, so the moment m which is drawn in blue color, which is that moment? It will be at both sides, not only one side. It will be at both sides.
mx.
The moment which is drawn in blue color. So which moment is that? Blue,
my.
my, because we have the local axis y. This moment is parallel to the local y. That's why it will be treated as a my. Okay. And now, but obvious, this is x, so this will be mx. Okay, understand?
Yes, son.
Now I will choose another different color, let's say green. So suppose this is my top slab. Okay, I want to provide a reinforcement in this direction. So to calculate this direction, this reinforcement, which moment I need to find?
MX.
MX. Why MX? Why MY not? Why not MY?
It will create the bending moments which is perpendicular to this reinforcement.
Yes. So if I want to find a reinforcement which is parallel to the local X, then I need to calculate the mx, correct? Because this plate will try to bend like this, correct? I don't know how it will, because we are not going to in that profile, but something like that, correct? So bending will be parallel to that local x. So in this direction, if you want to find out this moment, a reinforcement, you need to find out the mx. Okay, so now I will select this orange color. So obviously now in this direction against 90 direction, or maybe the reinforcement which is parallel to the local y, we need to find out the my. Clear?
Clear, son.
Okay, so now this is our only top slab plate. So if I open, I don't want this. If I select any plate, this wall plate, I will select this one and just go to that one. Okay. Okay, now this is a wall plate. I want to provide the vertical reinforcement. So for that, which moment I need to find out?
MX.
Correct, mx. So no option for the other thing. So for horizontal reinforcement, we need to find out the my. Clear? So now you can use reinforcement values. So you know how to extract the different moments for the top slab, base slab, and walls. करेक्ट? करेक्ट है ना कि आपको क्या ढूंढना है वो अभी आपको पता चला, कैसे ढूंढना है आई विल
Yes, sir.
एक्सप्लेन. ठीक है?
Yes, sir.
So this figure is very important. So you have to remember this for your entire lifetime, because you are designing, you are structural, you are working now, working as a structural engineer. So this is the lifetime. You have to remember this as a lifetime. So whenever you create this slab or plate, you should remember this. Just go to your local axis, open that, and just understand which direction you want to provide the reinforcement. And for that, you have to select which one, correct? Whether it is mx. So what happens, sometime you will prepare a plate in different direction. So in sometime what happens, so this y will become somewhere here, x will be here. So this is not fixed, this is our method. So someone will be created geometry differently, and in that case what can happen, so maybe this is local y, this is local x, and this is local z. So in this case what can happen, so if you really want to provide the vertical reinforcement, to find a vertical reinforcement, in this case which moment you have to find out?
MY.
Correct. So basically you have to check every time your local axis, and based on that you have to check. So it's not hard and fast that for vertical reinforcement always my will be there or always mx will be there. So prepare your geometry, and once you are coming to that stage where you have to find out the moment, so check its local axis, and based on that local axis you have to put, or you have to note down your values, so you can design your rebars or reinforcement, correct? So this is not constant, so these are the local axis, they will be changed because those are not global axis. Okay, so that's why this figure needs to be very very important, and you have to remember it for your lifetime. Very simple. The moment which is parallel to x, that is mx. The moment parallel to y, that is my. Finish. Okay, so now we are done for this basic things. I will just show you something. So now we are going to extract the results, but like deflection, so can we extract the everything together? That is also possible, but it will be little difficult. So if I go to the post processing mode, there is a one command, plate. So because we don't have any beams here, okay, so I click on plate, so it will ask me different parameters. So I want to find out first mx, okay, and that is global, not global, local axis. By default we are getting the mx for mx as a global local axis, sorry. So now yes, you can see this, you are getting everything in terms of mx. So these values are maybe from the top slab, side short wall, base slab. And if you see this table, click on the summary. So this is the summary of the plates, okay, but you don't know from which it is coming. So what you need to do, so maybe you can do same thing like we did. So better to understand, I will just select only. You can go back to your groups. Before that you need to go to the groups lab. We will start from the groups lab. Okay, now again go to the post processing mode, plate, just select mx. So now it is looks like better way, correct? Otherwise these left side values are for all the entire tank. Now these values are just for the roof slab, and if you go here also, now you will get the reaction for the roof slab. Not sure, but to make sure that, just right click it, go to the result setup, range, select to the range, go to the, like this is now only for the long wall, so I want to see this for the roof slab. Okay, so now all the values, those are represents for the roof. Okay, at the last you will see this mx 68, bending moment mx my. Okay, okay, now you can compare this. So maximum, these are the, you can see this load combination. So these are the service level load combination. So now we are going to design the slab. So always we need to find the factored load combination. So again, right click on this result setup. We already selected range. So instead of the service combinations, I want to use the factored load combinations. Okay. So for that, I will select the factored load combinations. Now these values are get changed. So maximum bending moment, that is a positive, that is 85, and maximum negative, that is coming as a 86, 61. But if you compare these figures are not matching. Why not matching? Because these loads are for the load cost 100. So we need to go to that load combinations, which that 202. So if I go to that 202, we can see this, it will be matching. Okay. So you can see this 85.66, 85.66. It used some rounding off. That's why. Otherwise, minus 61.874 minus, where it is that minus. So it is giving more than that. That's why 20 point something like that we are getting. MX, we are getting 61. Why it is not showing there minus 61? 202. Minus 20. Yeah, that is matching minus 20 and 20. 20.8. Now it is not matching, but if I select this plate 317, so this center stresses is matching, so no problem for that. If you see this maximum MX negative, MX 20.76, and we are getting the same thing, 20.8. Okay, so now we want to design this. So now again, so basic things. So this is our top slab. So anyone want to understand why this is like this? So this is roof slab. That's why what I did, I just deleted some plates here to consider as an opening. Okay, so we need some space to enter the tank. That's why what I did, I just simply deleted 3 plates, 3 into 6 plates here, so we can have some opening through the slab. Okay, so just assume a random size and just deleted 6 plates. Okay, so now we want to design. How to design? So this is a shorter span, correct? So the top slab is supporting on this way, so these are the shorter span. And if I go to this, these are the supports, shorter span. I'm trying to, this is fixity, not simply supported. Okay, this is the fixity and shorter span, means this one. We are getting red, that is a positive 85.7. And at the support, if you see at the support minus 20, where it is, what is the color showing here? Something like maybe purple or dark chocolatey. So it is coming somewhere at the edges. Okay, if we see from edge to towards to the center, what happened? Minus values are changing to positive. Okay, and at midspan it is maximum. So what and how it is a bending pattern for this? So for any fixed beam, what will be the bending pattern? So it will be like this: fixity at the support, and negative moments at support, and positive moment at the midspan somewhere. So somewhere here we are getting maximum positive moment, and at support we are getting maximum negative moment. So we have to observe this pattern. It should be like this. If not, then something is incorrect. So that's why I'm saying, so our first understanding should be very clear. Then you can compare or you can refer. Oh, so I'm expecting this pattern, and yes, my stat is giving similar kind of the pattern. So at the edge, I'm getting maximum 20. If I little bit come towards the center, it is going to reduce to 14, then again -7, -2.8. Again, I'm again started 0.5 positive. And when I reach somewhere at the mid span, I'm getting maximum positive value of 85. So same thing I'm getting here, correct? From 20 -20 to positive 85. Got it? What I want to say? ये स्टैड में से वैल्यू कोई भी निकाल के डिजाइन कर सकता है, लेकिन ये डिजाइन क्यों, ये कैसे आ रहा है, why it is coming, whether it is correct or not. So that is more important than the design. Okay, so if anything is incorrect, suppose in case you are getting 0 here instead of 20, so in that case what happens, so your modeling is something different, incorrect, or your results are getting incorrect. So that should be, rather than you मैंने मुझको स्टैट ने दिया है तो मैंने क्या किया, मैंने वही किया, तो नो. So that judgment we need to gain from our some basic structural engineering understanding from that. Okay, clear?
Yes, sir.
So this is for the main, because our main span like this. So same thing we have to do for the my. So just instead of select mx, you can select my. You will get the different contours here, and if you change the load combinations, all the values at the right or the left side, it will be get changed. If you just scroll down from 100 to 101, 102, 103 to 200 up to 300. So you can see the my values will be get changed. So for that, you don't want to see this, which, so again for that you can go to the summary. Okay, so we can know which is governing from which load combination. So if you don't want to see 100, 200, which is governing, so you have other option also. You directly go to the plate, my, go to the summary. Now you are getting the maximum values for that the plate. So you can see mx maximum, which is coming for the load combination 202. Same thing, my also coming for maximum load combination number 203. So from here you can choose or you can select load combination and you can refer, or you can go to the again the modeling and select. So same thing you need to do for the wall also. So instead of roof, I will open one wall. Maybe I will go to the group for that long wall. Instead of two, maybe I will keep open only one wall to avoid the confusion. Okay, go to the post processing, go to the plate, select mx. You are getting mx. These are the values for the mx. For load combination 200, you can little bit play it with, go to the load 201, 202, 3, or you don't want, you can directly jump into this summary. You are getting the maximum values for the wall, but make sure that you are in a correct group. So go to that result setup, go to the range. Loads are fine, 200 means factored, but these are the figures, these are represents for the roof slab. So just change to the long wall. So now these values are coming for the two long walls, even though we are just uh, see only one wall, but we are getting these values are for the two long walls. But that's fine. We are not going to design separate walls. We are designing for only one wall, that is long wall. Okay, so same thing, mx, you are getting mx for maximum mx for load combination 203 and minimum for the 203. If you want to find the maximum my, that comes for the load combination 202. Okay, and same thing with shear force, that is sqx and sqy. You are getting maximum shear force for load combination 203. So for shear force, generally I recommend don't fall into SQX and SQY. Just make sure that you are using maximum out of this. Okay. So in this case, maximum we are getting 292. Okay. So that is the shear force. But can you see what is the unit of the shear force in the STAD which is giving us? What is the unit SQX?
Kilonewton per meter square.
And what is the unit of the shear force that we already use?
Kilonewton.
Kilonewton. So what we need to do, so these shear force are coming for the per meter square. Okay, per meter square. So to convert it into the kilonewton, we need to just multiply by thickness of the plate. Suppose this is a wall, so what is the thickness? 500. So if you multiply this 291, I'm just coming using the round figure, 292. Let's assume 292 into what is the thickness? 0.5. Okay. So we are getting maximum shear force of 146. Okay. Got it? Every
Yes, sir.
every every time you have to multiply by thickness. Okay, thickness. So you will get actual shear force in the stat or in the model, whether it is a wall, whether it is a base slab, or whether it is a top slab. So same way you can calculate the mx, my for wall. Now we are talking for base slab. So we gone through how to calculate mx, my for top slab walls. Only remaining part is a base slab. So I'm just going to group base slab. I don't want to see this support, so I am going to off this. So for base slab also same thing. If you want to see these moments, bending moment, shear force, you can go to this, select anyone mx. You can see these different values. Again, go to the summary sheet, right click page setup, change your group, go to the base slab. Now you can find all the values which are corresponding to the base slab. So same thing, I'm not going to repeat it again. Only thing will be shear force. So we are getting shear force as a 392. And what is the thickness? Thickness is a 600. So what I'm doing, 392 into 0.6. So for base slab, we are getting maximum shear force as a 336 kilo Newton. Okay.
Yes, sir.
Okay, maybe I will show quickly how to create a report also, because making report also a very important things once you are doing the analysis and design, but you need to prepare the report also. So for that, what I will do, I will try to show you report also, maybe for only one element, because everything will be going to repeat it for the same thing for the top slab, roof slab. So maybe we will go for you tell me for which element you would like to create a one report, for top slab or wall or base slab.
Base slab.
Okay, or maybe I will try to add this for. So for creating detailed report, you can do like this. So suppose you want to show all the dimension that you are doing, like this is my base slab dimension, this is my base slab dimensions, this is my wall height. That's fine. Okay, maybe you can show the toe width also 0.3. You want to show this roof opening, that can also you can do, or maybe you can show this.
Sir, extremely sorry for the hindrance. Okay, one student called Venu, he is unable to join the class. It seems he just messaged me now. If you can accept him, that would be very good, sir.
I don't know whether I can accept it or not, but I will call Pragya madam, so maybe she can.
Okay, I'll message him the same, sir. I'll tell him to contact her.
Okay, because I think I don't have that authority to add, because I also need to ask Pragya madam to allow me that.
Noted, sir. Got it. Okay, thank you.
Okay. Or I don't know, means how he from
He
here.
can message in the group. So Pragya
Yes.
ma'am can directly see it and help him to join the conversation.
Okay. Okay.
Message on the main group. Okay.
Yes. Yes. No problem. Yeah. Because I think I can do that. Okay, so like this, you can create your some geometry. Suppose if you want to prove that, yes, based on that drawing, I have created my model. And for example, yes, so you can see these are the dimension. Yes. Okay, so you can add some dimension. Here you can take a snap of this entire snap. You can do something like that. Tank. So now you want to just go with the base slab. So okay, go to the base slab, select this slab. Go to the 3D view. Now I don't want to see all these dimensions, so I'm just going to delete this. So now we are going to prepare a report. How? Or maybe I will again add some dimensions for, I think no, not required. That's fine. For that, what I will do, I will go to post processing, go to the plate, MX. For that, summary, range, select to the base slab. For maximum MX 203, 202. Okay, I know which combinations is governing for MX and MY 203, 202, and for shear force 202. Fine. That is SQX. So what I will do, I will directly go to the 203. So I am getting maximum moment. So again, I will just click here. Just for your understanding, give us a name such a way so you can understand. So maximum MX base, it's up to you what you want to assign the name. I just copy this. So this is now MX. Just go to that this level, change it MY, and now go to the 202, because maximum MY moment is coming for 202. Okay. So again, take the snap, change the name Y, done. Now shear force, that is SQX. because we are getting maximum as a x cube x for same load combination. Maximum shear. So these are the basic things. Again, in addition to that, since we are doing the base slab, we need to find out the safe bearing capacity of the soil. Correct. So for that, what you need to do, just go to the this and base pressure. You are getting the base pressure here. Remember, these are the factored. So you need to just select such a way that we are getting the service level. So just check for 100 load case, what is the maximum bearing pressure? 60. Just go to that. 101, we are getting 64. 102, 121, 102, no, 121 is a maximum. So, okay, so we need to take this snap or SBC check, you can say SBC. So done. So we are assumed that our maximum safe bearing capacity of the soil as a 300 kilonewton per meter square. So, and what we are getting maximum bearing pressure as a 121 kilonewton per meter square. So it is obviously less than 300 meter. So it is safe. So we don't need to change anything. If it is failing, so maybe we need to increase the size of the slab. So bearing pressure can be little bit less than 300. Okay, understand what I want to say?
Yes, sir.
Okay, so now go to that report setting. Go to the report setting. What you want? Maybe input. You can add. Generally, I don't add. I will just start direct with the load combinations. Or suppose if you want plate thickness, this you can add. Support also you can add. These are the very important primary load cases and load combinations. So those are from the input data. Then go to the picture. Then select all pictures from 1 to 5. You have added that. Now go to the output. Yes, for the roof, for the base slab, you need maximum deflection. So select this node displacement summary. Always select summary because there are thousands of nodes. So you don't want to create more than 1000 pages of report. So just select summary always. So this will gives you the summary. Okay. And stresses. Plate center stress summary. Now you need to select the load combinations also. So actually what for displacement, we want only service level without factored. And for the summary, we need factored. So we cannot add both at the same time. But for just for your explanation, I will just keep as it is. I will select only factor load case now. But you need to do this 2 times just for the stress summary. I will select all this. Okay, so now everything is set. Just go to this preview. You are getting all these plates. So that's why I don't want to select these plates. I will just remove these plates. Support also. So I don't want, because it is giving the list for plate node number 1, which type of support. If you go to the next page, so maybe more than 200 page will be just occupied by this support. Okay. So that's why I will remove that also. I don't want that support. No, that is fine. Generally, I start with from this only, primary load cases. And yes, so these are the basic load cases, what we have adopted, the different load combinations. So those are here. If I go to next page, so you can see this. So this is the entire model with some dimensions. Now we are getting this maximum moment for the base slab. If I go to the next page, maximum moment MY for the base slab, and this is the maximum shear force for the base slab, and lastly maximum sub bearing pressure for the base slab, and these are the maximum deflection for only base slab. And on next page we will get the stress summary in terms of mx my. So you can print it, save it, PDF. Give some name, base slab report. Yes, so now you will get the base slab report. So same way, okay, so same way you have to create it for roof slab, you have to create for walls. Same thing we need to repeat again. So I need to show again it for another element, or can we move forward? It's up to you. It's same thing, just we are selecting a different element.
We will go to next, sir.
Okay, okay.
Yes, sir. Yes.
Okay, so now what happened? So we need to so this way we can extract all the values in terms of mx, my, shear force for every element. Now next part will be the design. How we can design? So now again we have two options. So one option is like the classic way that we did in our academics. We solve our structural design paper for 16 or 21 marks. So same thing, do it manually. That is the best method initially once you are new for this. So I strongly recommend do that. Take a paper, take a calculator, take a reference book, and do it manually for each element, for base slab, top slab, or roof slab, or walls. Okay, so that is, I will show that, I will share one reference for that. Okay, but I have another method also. So I'm not using the STAAD for that concrete design, because that format and which is not suitable, and we need to do some modification into that. So generally I never use any design which is come through the STAAD. But for that, what I did, I have developed one Excel sheet. Okay, I have developed Excel sheet. So in that we have to just input our all the results, so we can get the reinforcement design. Okay, so I will just explain quickly into that Excel sheet. Okay, so this is that Excel sheet that we have created. I will share with you also. Is it visible?
Yes, sir.
Yes, sir.
Okay, so the cells which are highlighted in yellow, so that needs to be changed only for you. So like this is the very generic things. So depth of the structure below ground, so that is a 5 meter. What is your grade of concrete, grade of steel, unit weight of the concrete, unit weight of PCC, unit weight of the water. So these are very generic things. Surcharge, what surcharge you are considering. Okay, instead of 5, maybe you can consider the train. Okay, natural ground. So we will get some drawings. So based on that, you can update those things which are highlighted in yellow. Okay, so if we assume soil bearing capacity as 300, so just change it to 300. So angle of repose, so just change based on that. We are assuming hard rock seismic zone, so I don't want to go into that, but since we are using this as a professionally for our projects, so we need to just add all the parameters. That's why those are mentioned here. So maybe if it is seismic related things, you can just add those things, seismic parameters, wagara wagara wagara. Okay, covers are added here. Okay, for roof slab, what are the cover, outer face, so everything is there. Subgrade of soil modulus, yes, we find the same thing, we calculate that same thing here, 17,500. Okay, for stability, so what you need to do, so we need to input these values. How to input these values? So this is someone else, so just save as this file and go to your stad value. Just prepare, just open one new sheet just for your reference. Okay, and go to your stad, go to your post processing method, displacement result setup, change all the load combinations because we are finding out the displacement for service level, select all. Okay, so we are getting this table which is applicable for entire time. So copy this table, go to your blank Excel sheet, paste it here, and just mention here somewhere just for your reference, deflection. Okay, now copy all the values. Copy all the values. You don't need to copy this mx, my. Just copy all the values including the load combinations or load. Okay, copy, go to that main sheet, select this corner, right click, paste special values. Okay, now you have paste all the values from your actual tank. What is the maximum vertical deflection is? That is 8.116. So just change it, 8.116. Maximum lateral service outward sway lateral, it is 1.4 to 1.2. So 1.4 is a maximum. Okay, 1.4. You can get this in your stat also. Just use highlighted value. Maximum lateral deflection 1.4, maximum vertical deflection 8.1. So I'm just put those values here, 8.2, 8.4, deflection criteria 360. You can change it as per your requirement. Height of the wall, that is 5 meter. Maximum allowable deflection 13 mm. Yes, you will get this pass. Done. This way you are done with the self check deflection. Okay, so maybe I request, maybe we will stop here because I have to go outside for due to some reason. So instead of, I will not extend today's session for more half an hour, but definitely we will continue in the next session. In that we will complete our analysis and design for rectangular tank, and we will start on clarifier, or maybe you can consider as a circular water tank. Is it fine?
Okay, sir.
Okay, so we will meet Monday, same time at 7 o'clock. Okay.
Please share the design reference.
Yes, maybe you can check with Pragya madam. So she already have this.
Okay,
So
sir.
if not, in next session, let me know. I will share again because I don't know means how to so I think your group is already created. So if she post everything that reference material to that your group, so it will be get automatically to all students. That will be ideal
Yes,
instead of
sir.
I'm just sharing it one to one.
Okay, sir.
Okay.
Okay.
Okay. Thank you. Thank you. And enjoy your weekend.
Okay, thank you, sir.
Thank you.
Good
Bye.
night,
Good
sir.
night.
Thank
Good
you,
night.
sir. Good night. Bye.